Welcome to this session on the flow of behavior-driven development and test-driven design. What are the objectives of this brief session? Well, they're twofold. One, understand how development flows using behavior-driven development, acceptance test-driven development, and test-driven development. And second, just see an example of a remote studio that I use for training. That's what you see here. Now, who am I? I'm Ken Pugh, for those who haven't met me on LinkedIn. I'm the Chief Consultant for Ken Pugh, Inc. I'm the author of 7 books that include Lean Agile Acceptance Test-Driven Development, Better Software Through Collaboration, on which the courses are based, Pre-Factory, on Design, Extreme Abstraction, Extreme Separation, and Extreme Readability. And that won the 2006 Jolt Award. Finally, I'm also the co-creator of the SAFE Agile Software Engineering course. So let's start with 2 principles. The first principle, no code goes in till the test goes on. No code goes in till the test goes on. This is shift-left testing or test first. We do not start an implementation until we have a test that tells us what that implementation is supposed to do. And the second principle is there are exceptions to every statement except this one. What I mean by that is I'm going to be showing you a flow, and these flows are simple, but there'll always be an exception to these flows. And so, if you see a flow and you have an exception to one of them, feel free to raise the exception, message me on LinkedIn, or send me an email you'll see at the end of the session. So let's look at development flow. First, we need to decide whether we're going to do something. And once we've decided that, we're going to do a bit of an analysis in order to figure out what the details of that requirement are. Then we'll do a little design, little code, some test, finally deploy it to staging, and then send it to production for execution. Now, this is a straightforward flow. You might have a few loops, or you might be doing a few things in parallel here. But this is fairly common flow. Now, we should be able to get something, once we've decided it, and get it out into production relatively rapidly. But there's always problems. Defects. Something that doesn't work right. What happens? We find something in testing, and it's a bug, and we have to go back to coding. Perhaps we find something in testing and realize we didn't understand the requirement, and we have to loop back to then. Or, probably one of the worst, we find something in production and we realize that maybe our requirement wasn't right, and we have to go back to that step. All of these loopbacks slow down the delivery of value to our customer. So let's start with a scenario. A scenario represents a behavior. And here is an overall scenario. Simple thing for an online ordering system. The scenario is get an item. Given the user wants a widget, when the user orders the widget, then the widget appears on the user's doorstep in 3 days. Given, when, then is a common template for scenario. Now, every scenario defines a behavior, but it also defines a test for that behavior. If we do the given and the when, and the system does not provide the then our system is not passing the test. Because the scenarios represent both behavior and test, we have 2 terms for their creation: behavior-driven development and acceptance test-driven development, for tests for the acceptable behavior. And who creates these scenarios? Well, the triad. That is 3 people that have the perspective of a developer, a tester, and a customer. and all three are responsible for quality. Let's look at a context diagram. Here is our online ordering system. The user interacts with it by placing an order or a widget. The next interaction is that widget appears on their doorstep. There is a straightforward context for a system. But we always like to create one of these because we realize that maybe there's a major player external to our system that we've left out. In this particular case, it's the credit card processor. Otherwise, we'll never get paid for that widget. And the credit card processor interacts with our user by sending them a charge, but that's external to our online ordering system. That's part of another system. Now, here's our context for our overall big flow, but we don't create things that are just monoliths. We'll have individual components, applications, services, and so forth that provide the services that are needed to fulfill that external scenario. In this case, we probably will have an ordering component that will actually do the credit card charging. And it'll turn an order over to our packaging component, which will then turn it over to the transport that actually then delivers the widget. So we have one view of our scenario in a context diagram. Here's a second view. Let's, in fact, add a little more detail to that scenario. Given the user wants a widget, and the company has at least one widget in stock for a price of $10, when the user orders the widget, well, that is going to appear on the user's doorstep in the 3 days, and we got to have an interaction with that credit card processor, and we're going to charge $11.75, including shipping and taxes. Now we took a very general scenario and have added a little more detail to it, still from the external view of the system. So there was our flow for a get an item scenario. It has select item, order item, package item, and transport item. And our get an item scenario encompasses all of those individual steps. Now this is a flow. It could be a workflow, it could be a value stream, it could be a customer journey. Lots of different names for the same idea of something that flows from one step to the next. Let's take a little part on a lower level scenario of that flow. Here's order an item. Given the shopping cart has at least one item, when the user submits an order, then the order is sent to the warehouse for packaging. And the credit card is charged. Well, how does that fit into our flow? We have our overall flow. Now we're going to have a flow for order item. And our order item scenario is going to have a compute tax and a compute shipping and a get payment and a send to shipping. You could also add a little more detail to this order item scenario. So here's order item again. Given our shopping cart has at least one item, that widget in there for a price of $10. When the user submits an order, then the shipping and taxes are computed. The sales tax of 75 cents, the shipping of $1, and our credit card gets charged $11.75. Now we can even move further on down. There is our order item scenario, and underneath it, underneath the compute tax, we have a compute tax scenario, which is going to be involved with just the computation of the sales tax. So let's look at that scenario. Compute tax. Given our order total is $10 and our address is Durham, North Carolina, when the sales tax is computed, then the sales tax is 75 cents. Very small, detailed scenario. And We call those either business rules or business calculations. And I have a rough estimate that at least 50% of the code in this world is all about business rules and business calculations. And we can easily create scenarios for them and automatically test them. Now, this compute tax also implies that we might have something like some data associated with it. For example, here are the data for the sales tax rates for the states and the counties. Durham is 7.5%, Wake is 7.25%, and if you live in New Hampshire, you don't pay a sales tax. Of course, we would have a large set of data along that same line. So let's look at this compute tax scenario. We've gotten now to the bottom of the flow, and now we start our design. What components do we need in order to implement and pass that compute tax scenario test? This is design. And typically one would like to create 3 ways to do a design and then pick the best one. So one might say, let's have a sales tax component, a location determination component, and a calculation component. 3 components. Now, should the calculation component call the location determination and then call sales tax? Or should calculation call sales tax and then calls location determination? Well, there's 2 alternatives. I'll let you figure out a 3rd way to implement this. But now we're down at the implementation level, and these scenarios are going to be created by the developers. In addition, each one of these little components could even be broken down farther. For example, sales tax data could be broken down into the sales tax data retrieval and the sales tax data update. Scenarios all the way down, some determined by the triad, some determined by the developers. So let's see what the flow is like if we use BDD, ATDD, and TDD. We decide, just like we did before. We analyze, now creating the scenarios/tests. We're going to either do our flow or our calculation scenarios, a flow and particular steps. Next step, we're going to design with those tests and utilize those tests in helping our design. During our design, as we decide what components we need, we'll create our component scenarios for higher level components and lower level components. And then we're going to start coding with the test. And we'll use those component scenario tests during our coding phase. We'll do some tests, and notice we'll do a lot less tests because this will be more exploratory testing. We've done most of the functionality testing in these 2 stages. Then, when we deploy, we'll be utilizing some of those tests from both the flow calculation and the component scenario. Finally, we send it into production and execute. There becomes our flow. Now, let's look at what we had before. We had these loopbacks from test to code, test to analyze, and execute in production back to analyze. Let's see what's happened with some of the people that I've taught ATDD, BDD before. Well, one place actually had rework of 60%. That means that 60% of the time, some code went to test it and it came back from test. Within a couple of months, that had been decreased to 20% and it fell off past then. Now, that eliminated that loop back. Getting the business rules right. Well, coming up with all the scenarios, all the variations, and all the edge cases before it was coded. Now, we didn't find out about things in tests and didn't have to go back to analyze the requirements, eliminating that loop back. One other place, in 3 subsequent deployments, actually had 0 production defects. I know that's hard to believe, but it actually occurred, and that eliminated that loop back. What are some of the other benefits that people found? Well, crisp, visible story completion, because we create the scenarios and those become the test. Once you pass all the tests, the story is done. And in creating those scenarios, we had the triad get together to collaborate, and that gave us tighter cross-functional team integration. A lot of benefits from doing BDD, ATDD, and TDD. And that gave us great flow. So, how do you experience BDD, ATDD, and TDD? Well, I've got a couple of workshops that I do remotely, as well as in person when that's available. The first is Lean, Agile, Acceptance Test-Driven, Behavior-Driven Development. Better software through collaboration. And this involves a triad. In this workshop, we want the product owner, business analyst, some representatives of the customer, we want representatives of the testers, and we want the developers. We want everybody in there. Because in this workshop, we use the team's real stories for the exercises. And we need all parts to be able to collaborate. So it's both a collaboration and a learning exercise. How does it work? 2 half days for all the teams, and we have a lot of breakout sessions during that time, and the teams work on their stories. And then we do a half day with each team, finishing off the story that they started and doing more of their stories so that they can embed it into their mind, the process for creating scenarios and tests. Now, for the developer side, I have got behavior-focused, test-driven development and design. And we talk about using scenarios as tests and creating alternate designs and figuring out which one is the best to pass those tests. And this consists of 5 half days. And the breakout sessions are in pairs, typically 2 developers, but in some places, a developer and a tester. If you'd like more information, you can contact me on LinkedIn. I'm Ken Pugh, or just send me an email, ken@kenpugh.com. So, thank you very much. Take care and be safe.